Section 5.4, the fundamental theorem of calculus 1, the fundamental theorem of calculus part 1, and then the definite integral and the net change theorem. What is the fundamental theorem? Part 1. If f is continuous on the interval, closed interval a and b, then definite integral from a to b of f lowercase f of x dx is equal to uppercase f at b minus uppercase f at a. That means that the antiderivative of f evaluated at b minus antiderivative of f evaluated at a. And so this is the beauty of this, is that you can actually relate the net area to the antiderivative, and that was the whole story that we said all about the fact that the elongated sum shows up for both of them, and this is why, and this is how they are related. Now let's relate this antiderivative, the definite integral from 1 to 3 of x to the x squared minus 6 dx. And so how does this work? First, you take the antiderivative instead of approximating the area, then you plug in the limits, and taking the antiderivative gives me x to power 1 more divided by 3 minus 6x. Constant can be, you can put the constant in and then realize that it simplifies. And so what you find is 3 to the power 3 over 3 minus 6 times 3. And then minus, this part is the antiderivative, f evaluated at 3, then minus 1 to the power 3 divided by 3, 6 times 1. This is the antiderivative evaluated at 1. And so the first part you compute and you get negative 9, and the second one you compute and you get negative 17 third. And then finally you end up with basically negative 10 third. And therefore the function has that much area underneath the x-axis. Again, the fundamental theorem of calculus 1, calculus part 1, is that for continuous function, the definite integral from a to b of f of x dx is equal to f of b minus f of a, which capital F of B minus capital F of A, where the derivative of capital F is equal to lowercase f. And so now let's evaluate this one. Again, another definite integral. So I know I have to take the antiderivative first. So I have to find f first, and that would be, in this case, let's write it down first. And then remember, we have to plug in b and a. So put b and a right here. This is the notation that we use to plug in b and a. And so 2 cosine of t, the antiderivative is 2 sine of t, sine of x, minus 4x to the power 2 divided by 2, and 0 and pi half. And here is 2 sine of x minus 2x squared, 0 and pi half. And so you end up at 2 sine of pi half minus 2 pi half to the power 2 minus 2 sine of 0 minus 2 times 0 to the power 2. So this part, this is f of 0 is going to be 0. this is capital F at pi half. And that is going to be the answer, which is 2 sine of pi half, which is 2 minus 2 times pi to the power 2 over 4, which is pi over 2 over 2.